So as Keith said, I'll be talking through the process of characterisation of Irish free-living colonies using the DeepWings software. So Stephen already kind of touched on most of this background. The kind of main feature that we're looking at here is the Apis mellifera mellifera is the native subspecies across the UK and Ireland, and that's currently facing threat of introgression from sea lineage subspecies, those being Apis mellifera carnica and Apis mellifera ligustica. So beam morphometry, or kind of the study of the physical characteristics, was first developed in the early 20th century. It was mostly developed in 1988 when Fredrich Ruttner used a suite of 36 morphological characteristics to identify 24 individual subspecies of Apis mellifera, and this became known as standard morphometry. And morphometrics is still widely used today, mostly by beekeepers and members of the public who don't have access to molecular methods of identification. So in Ruttner's original 1988 work, 14 of his characteristics focused on wings alone. These included these 11 angles of wing venation you can see here, along with the forewing length, forewing width, and the cubital vein. Modern morphometrics, however, or modern wing morphometrics, now relies on the shape variations between 19 data points or landmarks across the wing, and these 19 data points are based on these 11 original angles. So here then we have these 19 data points. These are measured in X and Y coordinates, and it's the deviations in these positional coordinates that's specific for the subspecies of Apis mellifera. So previous programs that were developed always relied on some form of manual annotation to these 19 landmarks, which can be very time-consuming and introduces a huge amount of human error. However, Elise Pinto's lab developed DeepWings in 2022, and this is free open-source software that makes the process of wing morphometric classification completely automatic. Once you remove and mount and scan the wings in, then DeepWings takes care of the rest. When we are running our wing samples through DeepWings, we are using the 5 subspecies classifier, which just focuses on M and C lineage subspecies, as the threat to AMM here in Ireland is introgression with C lineage. This provides us with a really kind of good overview initially of the influence of C lineage subspecies on our natives here in Ireland. So here again we have these 19 landmarks, but the 4 that I've highlighted here are the 4 that are most important for subspecies classification. And these go on to form the cubital index, the Hansel index, and the discoidal shift angle. So the cubital index then is just the measurement of these points C, D here to DE, and it's a division of those 2 points. The Hansel index is then the difference between points C and E divided by points A, B in the radial cell at the top of the forewing there. And the discoidal shift angle is the degree of offset at the perpendicular junction between the radial cell at the top of the forewing and the cubital 3 cell. And this degree of offset is known as the D angle, and the D angle can be positive, negative, or 0 depending on the subspecies of Apis mellifera that we're focusing on. So here then we have all the M and C lineage subspecies with their cubital index and discoidal shift values. So you can see there's a degree of overlap between all these cubital index values, but it's the relationship between the cubital index and the discoidal shift angle that provides a happy median for subspecies identification. Using these 2 parameters, DeepWings achieves a correct identification of Apis mellifera mellifera 95% of the time, and this increases to 98.9% when looking at Apis mellifera carnica. So in 2022, we sampled 51 free-living colonies that encompass 10 counties across Ireland, and we removed the right forewing from 12 individuals per colony as soon as possible after collection and before we conducted any other kind of experimental work on these samples. So we analysed a total of 612 forewing images, and 96% of these were assigned to M lineage subspecies. Most of these being Apis mellifera mellifera and some being Apis mellifera iberiensis. Now, we don't get Apis mellifera iberiensis here in Ireland, So we believe that these results are due to the wings have been orientated slightly wrong, and it's producing a positive discoidal shift angle that's giving them the characteristics of Apis mellifera iberiensis. So we have a bit of kind of work to do on refining our methodology here. You can see also that the impact of non-native strains definitely isn't going unnoticed in the morphometrics, with 4% of our colonies being assigned to sea lineage subspecies, most of these being Apis mellifera carnica. To add validity to the wing morphometric assessments, you can combine them with assessments of colour, or more specifically tergite discoloration. When Ruttner was using his 36 characteristics, he also focused on colour, but he was looking at the pigmentation of the tergites and the sternites, so those dorsal and ventral abdominal segments. However, when we're taking abdominal discoloration into account, we're just measuring the presence of kind of banding on those dorsal segments of just the tergites. And you can do that by categorising individuals into one of 4 categories. Those being black, which you can see in this abdomen here, there's no presence of any discoloration at all. You can have spots present on the second tergite. You can see it's just starting to creep in at the top here. You then have banding present across the entire second tergite, or banding across the second and third tergite. So when combining morphometric and molecular methods, we used a subset of 46 colonies from County Donegal, and you can see from the morphometric analysis, 100% of the managed samples were coming out as M lineage, with only 5.5% of the free-living samples coming out as C lineage. This translates into just 1 out of the 46 colonies being categorised as C lineage. Abdominal banding presence, however, was identified in 25 of these colonies, and Stephen touched on the F3 statistic earlier, and we used this again here to identify that 11 out of 46 of these colonies were hybridised. So we can see already that there's a big disagreement between morphometric and molecular methods, with wing morphometrics having the tendency to underestimate the proportion of hybridisation, and abdominal discoloration having the tendency to overestimate the proportion of hybridisation. So there was another Irish data set of samples used in this paper in 2022, and they documented agreement between morphometric and molecular methods 98% of the time. However, we only saw that agreement in 47% of cases. Now, the Irish samples that were used in this 2022 data set were from 2019 and before, and we know that we've had an increase in the number of imports in the last 4 years. So we think that this is demonstrating that morphometrics has notable limitations for populations where there's varying levels of hybridisation, as Stephen was touching on earlier. The Irish population that we have has very much varying levels of hybridisation, which might not make morphometrics as suitable for colony identification. For this reason, we don't recommend using morphometrics alone as a method of classification, despite its kind of ease and simplicity. But we do recommend combining it with a molecular method of identification for entirely accurate subspecies identification. So I'd like to send my thanks to the team and all the beekeepers that were involved in all the sampling. It kind of takes a village to do one of these big sampling trips, so always my thanks go out to all these guys, and the supervisor Grace, obviously, for her wisdom and always helping.
Thanks, Alex. You finished ahead of time.
Good.
Right, throw it open to the floor again for questions. Darren isn't there yet. Darren, go ahead.
Well, that's correct. That was a really interesting talk, and I loved the bit with the colour banding. I never really believed the using colour to tell them apart thing, so it's nice to see some empirical proof of that. I might have missed it, but which population of AMM was the morphometric model developed on?
So he used kind of what would have been UK AMM at the time, I think.
I'm interested by the Iberiensis being popping up there, because that actually could be biological as well. There's a bunch of species in Ireland which show similar morphological adaptations to Iberian species. We're kind of a weird mishmash of British and Iberian influences in terms of morphology. Some of it is an Atlantic fringe thing, some of it is the post-glacial stuff. So it could even be a slight difference in the morphology of the wings here. Wouldn't be shocked by that, but it's very interesting.
Yeah.
Thanks very much.
That's a good point. I'll definitely keep that in mind when we're kind of going through it with a fine-tooth comb.
Sorry, Jane, go ahead.
Just a very similar comment to the previous one to Stephen is look at the similarities in what you're finding in the genetics and the morphometrics and the colours and the rest of it with the apis, with the bombus, and what's been shown in and this isn't my work, so I'm going to describe it really badly, but in terms of colour patterns and how you can use those to describe, but also look at the genetics. Yeah, anyway, just make that parallel between the bombus and the apis.
Absolutely.
Yeah, I think morphometrics as a way of absolutely defining certainly hybridization down to the lineage is still needs a lot of work, you know. As you rightly say, it needs to be just it needs to be mixed with molecular work. Okay, if there's no other questions, then we'll move on. Thank you very much, Alex.
No worries.